Okay, thanks for the introduction. And hello everyone, good morning.
Good morning.
Okay, thanks. And here's the slide link. And I know someone is not good at English listening, so I provide a QR code. If you are not good at that, and you can use your cell phone to scan your QR code, then look at the slide. So just wait for 5 seconds to scan the QR code. Okay. So today is my outline, and firstly I introduce myself and why hash, encrypt, decrypt, and my experience about this. So let me introduce myself. I'm Peter, and I'm from Taiwan, and my Chinese name is Junshen Li. But you can just call me Peter because it's a nickname and easy to remember. And here is my GitHub link. And I also an active open source contributor. And you can call me a backend developer, PHP developer, and okay. And I have 3 years experience about PHP development. And I use PHP 5.3 to PHP 7. And I use Node framework, then I use Zim, then I recently used Laravel framework to develop my web applications and service. And I also work for my it's a ITRI currently. ITRI is a government institute, and the full name is on the right picture. And we also research about smart grid technology and helps Taiwan power company to build their smart grid system. And why? I want to talk about why I want to share this presentation. It's about a true story. We are back to 2016. It's my team, and you can look at this picture. And this is my project manager, and it's me, and research engineer and vacation engineer. You can look at this picture, and there are four people in my team, but one is resign and another one is vacation. So one day, project manager asked me, one is will take pregnant vacation, and another one will resign the job. So you need to take over one project, and we can call XXX. So me is I think it's okay, but I'm the senior developer. I'm junior developer in this team, and the team will be 2 members. So after one day, they are gone. So it's me and the project manager. So every project are taken over by me. And look at this XX system. It's called about demand response system. It's a part of smart grid technology, and we use this system to help our company and talk about the electric demand response, and the Taiwan Power Company can know about how electric used in company, and it can and this system can also help the Taiwan Power Company to know the electric high status and the low status, and it can know about the electric power. It should be a system to monitor the electric data and the electric demand. So we can look at this system. This system is very old. The operating system is Ubuntu 14.04 and use now available 5.2 and PHP 5.59, and the project is no README, and it only has the source code. So I have no README, so I just one work to trace the source code to understand how they work. So I use the AG. AG is a command on Ubuntu on Linux system, and he can filter in your specific folder. So I want to know about how they storing the password in database. So I use this command, and I use MD5 to be keyword and find a specific folder. Then I find this one. Use the MD5 to secure the password. So I think something went wrong. Finally, I got a summary about how they use the MD5 to secure the password. The password storing hash on this system. Firstly, you receive a password from client, then using MD5 hash to hash passwords and store in database. But you can use Google and type the MD5 Risky keyword, then you can find some reference about that. Because the MD5 password hash is not security, and the hash result will have the collision. Then in PHP, MD5 hash equal has the tricky situation, and you can use you can look at this code snippet. You can look at this one. If you use the loose equal, and it will be true. So if you want to hash equal, and you have to use strict equal. But I don't recommend the MD5 hash. And I also find a website about MD5 Decryption. MD5 Decryption is the website will collect all hash results in their databases. Then you type the hash result, and he will try to use the dictionary attack to scan their databases, then find the current or the possible hash result. And the critical receipt I mentioned on the previous is called MD5 collision. And here are the two references about the MD5 collisions. And the MD5 collisions will have the MD5 hash collisions will know about okay, MD5 hash collisions you can it's a attack, and you can imagine that it's a it's a scenario condition, and it can filter something, and they can guess your possible plain text. But we know the hash is the one way, and it cannot reverse. It cannot be reversed. So the MD5 hash is not security. Is not secure. So my recommendation is don't do MD5 hash to store your passwords, but because it's not safe. If your database system is under the rainbow attack, and the hackers get your MD5 hash results, then he can use the MD5 collision and reverse all of the hash results to the plain text. So you have one question. If I don't use MD5 hash, can I use SHA-1 hash? SHA-1 hash has another risky. If you type the keyword SHA-1 risky, then you can find these results. And here is the reference link about the shelter.io. The shelter.io is talk about how they use PDF document to prove the SHA-1 risky. And this is a attack-proof picture, and he used the two PDF files, then do the attack about the SHA-1 digits, and it has the same as the MD5 Decryption website. Some hackers collect the SHA-1 result and develop a website to type the hash result. Then you can try to use one and then decrypt the possible plain text. And the SHA-1 hash approach is about is same as the MD5 hash. The plain text will be one of hash results. Every time you will get the same hash result with the same plain text. So you can look at this one. Okay, so if you still use the MD5 hash or SHA-1 hash, and you don't want to use the mother hash, this is my recommendation. My recommendation is about you can use the source with your password, then get the hash result, and it's the same approach as SHA-1. But my recommendation is don't use these hash functions because they are not safe. And if you are good at hash or something, about the security, then you will know about these hashes: SHA-256 or 384, 512, or SHA-3. And these SHA functions are very safe, and they don't find effective way to crack. If you use them, I think it's fine. But it's same as the MD5 hash and the SHA-1 hash. Some hackers collect all hash results, then store their databases. So you cannot avoid the dictionary attack. So the hacker will collecting the hash results, and this attack is called dictionary, and so he can use the dictionary files to search your hash results and find a possible plain text. So your hash result cannot avoid a brute force attack. So SHA-1, MD5, SHA-2, SHA-3 will not avoid a brute force attack, but you have to choose the proper hash. So you may ask the question: what kinds of hash should be proper? Okay, so firstly, we can look at the reference on PHP.net. The PHP.net is an official PHP website, and we can look at the function reference about MD5 and the SHA-1 function reference. So you can look at this picture, MD5 function reference, and there have the warning message. The warning message about is not recommended, and you have to use the password hash instead. Then be safe to store the password on your database. And it's the reason why you have to use the password hash function instead. And there is another reference about how we use the current password hash to secure the user passwords. And the website is called PHP the Right Way. And you can look at this, visit this link. And it's another reference about how to safely store your user password. And in 2016, it is in 2019, but I think it's fine to use these recommendations in 2019. And so let me organize all recommendations. And you can use the hash algorithms, and you can use the decrypt algorithm too, and they are part of the hash passwording hash competition. And these two hash algorithms are recommended by PHP.net. So look at the password hash function, and it's available on PHP 5.5.9. And if you use the PHP version, it's lower than this version, and you can use the password compact. But I don't recommend this function and this project, because this project is inactive now. So if you have to use the password hash function to secure your password, I strongly recommend you have to upgrade your PHP version. So this is about the password hash function usage. The usage is very simple. Firstly, you call the password hash function, then use the password default. The password default is a PHP constant, and then it will find the best hash algorithms in your PHP environment. And if you use the PHP 5.59, and it will use the password, it will use the decrypt hash algorithm to hash your password. Then if you want to verify the password, and you can call the password verify function, then use your password and password hash to verify the password. And here is the password function reference and their parameters. So password default uses the decrypt. And if you use the PHP 7 or PHP 8, it will change the algorithm, because PHP domain will choose the most strongest algorithms in your PHP environment. And if you don't want to use the password default to let PHP choose the best hash algorithms, you can use the following constants, and it can specify your password hash algorithm approaches, such as password decrypt, blowfish, and the sort option. You can specify your sort and specify your cost option, and the default is 0. The password hash algorithms are as follows. You can use the password password ID, and use the memory cost, time cost, and the threads during the password hash functions. And what is the memory cost? And it's about how it can tell the PHP to do this function. It can specify the memory. Then the time cost is about this hash algorithm features. You can tell the PHP this function, and to tell the time cost, it can call 5 times, 3 times, or 1 time to doing the hash work. And the thread is tell PHP you want to use how many threads to do this password hash work. And here is the Authenticated password hash example. And the example is about using the 1, 2, 3, 4, 5, 6 to hash this password. And you can look at this password hash result. And it has the prefix text. Is the Authenticated algorithm, and using the memory is about 6 megabytes. Then time cost is 4. Then thread is 1. Then after this prefix text, here are the password hash result. And if you want to specify your time cost, memory cost, and the thread, you can use the following approach. You can specify your time cost, memory cost, and the thread. Then the result is here. And it's the same as Argon2 ID. And if you use the Argon2 ID, the result will get the Argon2 ID prefix name and other informations about time cost, memory cost, and the threads. And if you don't want to use the password hash functions and hash about the function, or you use the novel framework, you can just use the hashing. The hashing is the class, and it's a class wrapper. Then it wraps the password hash functions, and you can just use the following example code. Firstly, you use this class namespace declaring. Then declaring is a hash make password and call the time cost 12. Then you can get the hash value. Then hash value, or you can use the following sample code to memory is about memory cost, time cost, threads. Then get your password hash result. So after the password hashing is done, then we can I want to talk about the encryption decryption, and it's called about the cryptography. If you use the cryptography to decrypt your plain text, you may know about this one. It's called Encrypt. But Encrypt is inactive in 2015, and there are many vulnerabilities and bugs. So here is the reference about this one, and it's talk about how don't use this Encrypt extension because the many vulnerabilities and bugs are not resolved. And here's the real reason. Encrypt bug, and it is the picture captured on the source port site. And look at this one. Last update. This last update is about the latest commit. It's on 2012. It has been inactive for about 7 years. And then if you don't have to use Encrypt extension. And I suggest you can use the OpenSSL extension to do the cryptography. And the most famous crypto approach is called AES-CCM encryption mode. And let me talk about the AES-CCM encryption mode. It's ECB, CBC, and CCM. Firstly, you can look at the ECB mode. The ECB mode is very simple. It's a plain text block, and using AES to encrypt them, and they need to group the plain text when ciphertext lost or tampered, and the plaintext will be run during the decryption, and it cannot verify the it cannot complete the cipher validation, and this mode is not recommended in any situation about using AES to decrypt and decrypt your plaintext. I know this ECB description is not easy to understand, so I draw the picture and look at this picture. Firstly, use the plaintext and your key, and the key is your specific, and the key and the plaintext, and you will get the block cipher encryption, and get one ciphertext, then ciphertext 2, ciphertext 3, and all of them are the encrypted result. So if your one of cipher are gone or are wrong, then you cannot get a decrypted result, because the block cipher depends on the previous cipher decryption. And I talk about the CBC, the cipher block training. Each plaintext block should use the XOR. It's a Boolean calculation, and it can use this Boolean calculation to cipher the block. Every cipher block depends on previous or plaintext blocks, and to guarantee or to verify every message is unique and is verified. So the first block should use the initialized vector. So look at this picture. It's a CBC mode. Firstly, you have to initialize the key vector, this one. Then use this key vector, initial key vector, then use the XOR with the plaintext. Then you can get the first block cipher encryption. Okay, and use the key. So you have to use 3 and get a block cipher encryption. Then you can get first ciphertext. Then use the ciphertext, then and the plaintext and the key to get the second ciphertext, and so on. And all of them are you can get the encrypted result. Okay, after the CBC mode, and I want to talk about CTR mode. The CTR mode is use the CTR1 and the key plaintext, then have the use the XOR calculation to get the ciphertext, then ciphertext 2, ciphertext 3. And the message authentication code is about verify your hash results, and you can verify your hash result is sent from your trusted client. And here is the message or authentication code. Firstly, you use the key and the message, and hash them, then you can do a message authentication code value. And is also together with the encrypted result, then sent to the another client. So if you want to have the mode and the message authentication code mode, you can use a GMake. And the GMake is firstly you use the Track6-1, then the message authentication hash, and do XOR calculation, then do, and you can get another message authentication hash, then and so on, and you can get a MAC value. And the GCM mode is a GMAC plus CTR, and this mode includes the message authentication code and the CTR mode. So it can provide completed encrypted message validation. And some messages should not be confidential. So it can let the receiver can validate the message. And the message includes the IP address, port number, and the target IP and the initialized vector. And these messages will be added on MAC value calculation. And it's the information about it's export information. So here is the GCM mode. And it can combine this one and this one. So it has a very big picture. So firstly, using the CTR mode and the key to get the hash, and another one is message and use the XOR calculation to get the ciphertext 1, ciphertext 2, ciphertext 3, and it can have the message authentication 1, message authentication 2, message authentication 3, then all of them is the encrypted result. So many modes are described. Then I show you how to use them. Firstly, you can use the OpenSSL Encrypt, and is available on the PHP 5.6 plus. And here is the sample code. The sample code is very simple. Firstly, you have to specify the plain text and the key, and use the OpenSSL cipher initial IV length function to initialize your vector length. And the cipher you can specify. And here is specify the AES-128 CBC mode. And you can use the OpenSSL to render a procedural byte to get the IV initialized vector. And you can use the OpenSSL encrypt function to get the ciphertext row. And the ciphertext row will be the binary. So if you want to send to another client to be convenient, I also use the best64 encode function to encode the ciphertext row before sending the hash encrypted result to the specific client. And here is the hash-make. The hash-make is another function to to hash your message authentication code. Then, if you want to ciphertext before sending to the specific client, you can use the initialize vector, then concat the hash message authentication code value and the ciphertext row to encode with the base64 encode function, then get the ciphertext. And once the client receives the encrypted result, he can use this symbol code to decrypt the encrypted result. Firstly, the client uses the base64 decode to decode the ciphertext. Then use the initialize vector length to get the initialized vector length, and to get the current initialized vector and the hash message authentication code value, then it can get the ciphertext row. And the initialized vector length and the hash message authentication code value is a constraint length. So it's fine to use the substring to get the initialized vector and the hash message authentication code. And here is the OpenSSL decrypt. Then the client gets the ciphertext row, and he can use the hash decrypt to get the original plain text. And if you want to validate the hash message authentication, you can use the hash equal to verify the hash mate and the calculated message authentication code is equal. If it's equal, it's true, then you can know that this encrypted result is sent from your trusted server or client. And if you use the PHP 7.1, you can use the following sample code to do the OpenSSL encrypt. Firstly, you can use the AES 128 GCM mode, and the GCM mode is more powerful than the CDC mode. So here is the in array function to make sure that this cipher mode is included. Then you can just use the OpenSSL decrypt and encrypt to decrypt the original plain text. And after using the OpenSSL to encrypt your plain text, I also introduced about sodium, and there is another one about modern cryptography. And this modern cryptography is available on PHP 7.2. And the sodium details are as follows. It has the ECC and the Argon2 and the Encrypt and the AES-CCM mode. Sodium details are included many hash and cryptography features. So I I introduce the Argent2 and the AES. So you can why we want to use the sodium, because this function and these features can avoid the side channel attacks. What is the side channel attacks? Sometimes we can we can monitor the CPU activity and guess the current plain text. And the sodium will avoid this attack, because he will change or free the memories and the CPU usage. So the attacker cannot use the side channel attack to try to decrypt the encrypted result. And the sodium is available on the PHP 7.2. And if you use the PHP 7.0, 7.1, and you can use the PCO to install the sodium extension. And the sodium, the use cases are as follows: encrypt and authenticate with a share key, and sending a secret message. Then you can generate the digital signature and authenticate the encryption with AES-CCM mode. Or you can use the sodium to store a password with the Argent2I. And firstly, here is the example about use the encrypt authentication with a share key. Firstly, you generate the key with random bytes. Then use the non-random bytes to generate the required key nonce and you can use the key and the nonce to encrypt the ciphertext. And I think it's very simple. It's more simple than other, and it's very very simple, because the OpenSSL is very complicated. And if we use the sodium, it has the 3 function call, and you can get your ciphertext. And another use case is about sending secret messages. And here is the scenario. And Bob and Alice. One day, Bob want to send a message to Alice, but he doesn't want to let other people to know about what message is sent to Alice. So firstly, Bob gives his public key to Alice. Then Alice gives the public key to Bob. So he can use this one to encrypt their messages. And firstly, Bob sent an encrypted message to Alice. Then Alice used the Bob public key and the Alice private key and her private key, then to decrypt the message. And here is the example about this one. Firstly, Bob key pair is called a Bob private key and the Bob public key. And here is the Alice key, Alice public key, and the Alice private key. So they can use them to encrypt the message. So firstly, Bob sent encrypted secret message to Alice. Here is the example. So use this one. Sodium crypto pass key pair. Then Bob uses its public key and adds public key. Then generate the encrypted result. And use the best 64 to encode the encrypted. Then use this result to and pass sends to the Alice. Then Alice receives the encrypted message. And he can use her private key and the public key, then get the decrypted message. And if the Alice wants to verify the digital signature about the message, he can use the following code. Firstly, he uses the public key and the secret key, and use the sign message for this one. And if you want to verify the digital signature equal, you can use the original and the message. Use the string equal. And you can use the sodium crypto sign verify detach function to verify the message. Then authenticated encryption with AES-CCM. And the OpenSSL can do the same thing with the AES-CCM mode. And here is use the sodium style to encrypt and decrypt with AES-CCM. And here are the sample code. And here is the sample code about this one. Firstly, you can specify the message, secret message, then use the random bytes to generate the key, and generate the nonce. And your additional public data, and it will include in the message authentication code value. Then use them in the sodium crypto and AES-CCM mode to encrypt. And you can use the base 64 to encode the ciphertext. And if you want to decrypt them, you can use the sodium crypto AES 2056 this function to decrypt them, this decrypt result. And if you want to store a password safely, you can just use the argon2i. The argon2i, here is the sodium style to hash the password with argon2i. And here is the example. Firstly, you have to generate a hash string, and you can specify the password hash, the constant values is the memory cost and the time cost limit. And if you want to verify that, you can use the sodium crypto p.hash str verify function to verify the hash and the user input password. And this approach is equivalent to the password hash style, and they will get the same password hash result. And I also I also do the hash comparison with the sodium and the password hash function. And here is the comparison hash 1997 and the length is 1970 and 1960. So other two are hash compatibility. And if you use this one, sodium, crypto, and the password hash, they will get the same hash result. So it will get the same result. If you use the other two hash compatibility check, you can use this one with the sodium and use the password hash function, and they will get the same result of the password hash. And then if you want to free the memory and it can avoid a side channel attack, you have to use the sodium man0 and to avoid side channel attack, because it will reset the CPU process usage and it cannot track the memory or something information on the memory. And if you have about the sodium functions and the OpenSSL functions, you can just use the sodium wrapper and the OpenSSL wrapper, and they are available on the GitHub site. And here is the sodium wrapper. I recommend use this because you can use the sodium compact with the PHP functions with the pure PHP implementation, and you don't have to use the PCL to install the sodium extension. And here are the sodium wrapper, and you can use the OOP style to use the sodium conveniently. And here is the OpenSSL wrapper. And the OpenSSL wrapper will be convenient to use the OOP style to use the OpenSSL functions. And my experience. Firstly, I do the hash migration on this demand response system. I migrate to the password hash and upgrade my PHP version to 7.2. And the hash migration approach is as follows. Firstly, reset user password with decrypt, and forcing user to reset all passwords. And I can make sure that all users is under the decrypt result. And the encrypt decrypt application. And I use this as another service, and it's also part of smart grid technology. And I use them to encrypt the power plant big data and the message transmission message and the big data result to send to the power plants and the current power company. So here's my summary. Firstly, migrating to the PHP 7, and then don't use the Encrypt, using the OpenSSL or sodium instead, and then don't use MD5 hash or other risk hash approach. And you can use the password hash function instead. and I have no time to demo the darker environment. So, any questions?
もし必要であれば日本語で質問いただければ英訳します。
So like a securing algorithm, like choosing that to apply your application, how do you size your capacity, like a memory size or time cost, or how do you calculate that? How do you measure to apply your application?
Okay, the question is about how to use the memory cost, time cost to determine. Okay, it's a good question. Sometimes I use the default value to do the password hash because the recommended value or we can call default value, the official PHP team say is enough. So I also use the recommended value or default value during the password hash function.
Then like a checking benchmark or something?
It's another good question, but I have no time
I know.
to do a benchmark because I take over the system by myself. Maybe if I had available time, I will do the benchmark to determine the best option about time cost, memory cost. Thank you.
Thank you.
Other question?
Then お時間になりましたので、こちらのセッションを終わらせていただきます。ピーターさん、ありがとうございました。こちらの